Look up at the night sky long enough and a certain expectation forms almost automatically. There are hundreds of billions of stars in this galaxy alone. There are hundreds of billions of galaxies beyond it. With numbers like that, it feels unreasonable that life would occur only once. That feeling is powerful, but power does not make it reliable. Human intuition evolved to judge immediate threats, not cosmic probability. It helps you catch a falling object. It helps you navigate social hierarchies. It does not help you reason about relativistic limits or exponential growth. When you stretch it across astronomical scale, it stops functioning. So instead of asking why we do not see visitors, we should ask something more careful. Given the actual structure of the universe, what should we expect? Start with scale. Earth feels vast because it is the largest continuous environment we experience. Yet it is small enough that a commercial aircraft can cross it in less than a day. The Sun, at 150 million kilometers away, sounds distant, but light bridges that gap in 8 minutes. That still fits inside human time perception. Now move outward once more. The nearest star system beyond our own is more than 4 light years away. That means even light, the fastest possible signal, requires over 4 years to travel the distance. The fastest object humanity has ever constructed would require thousands of years. Not to cross the galaxy, to reach the nearest star. Scale expands quietly at first, then it breaks comprehension. The Milky Way stretches roughly 100,000 light-years across. If you attempt to imagine crossing it with any known propulsion method, you are forced into time spans longer than evolutionary history itself. A civilization attempting the journey would not be the same civilization that arrived. Distance is not merely large, it is structurally isolating. You might argue that technological progress solves this. Go faster, build stronger engines, increase efficiency. This leads directly to the second constraint. The speed of light is not a technological inconvenience. It is a boundary woven into spacetime. As velocity increases toward that limit, the energy required to increase it further does not scale linearly. It diverges. The closer you approach light speed, the more energy goes into increasing inertia rather than velocity. To reach the speed of light requires infinite energy. Infinite is not hyperbole. It is a mathematical result. The limit protects causality. If signals could exceed it, effect could precede cause. The logical structure of reality would fail. This means no civilization, no matter how advanced, can outrun it. Even if one accepts relativistic travel at a fraction of light speed, the journey times remain immense. A trip at 10% of light speed to the nearest star still spans decades from the traveler's perspective and centuries in external time depending on the frame. And this assumes propulsion is solved, which it is not. The rocket equation introduces an exponential cost. Fuel has mass. To accelerate fuel, you require additional fuel. To decelerate upon arrival, you must carry braking fuel the entire way. Each increment compounds the requirement. The numbers grow faster than intuition can track. Even with speculative fusion drives, most of the spacecraft mass becomes fuel. With antimatter, the production cost exceeds realistic planetary energy output. Advanced civilizations would not merely possess energy, they would understand its opportunity cost. Interstellar travel consumes extraordinary resources for uncertain gain. Already, before considering biology or communication, the structure of physics discourages casual contact. And that is only the beginning. Now assume, generously, that propulsion is somehow managed. Energy production is sufficient. Engineering hurdles are solved. A civilization commits to the journey. The next constraint is not mechanical, it is biological. Life on Earth evolved under one specific set of conditions: one gravity, one atmospheric pressure, one magnetic shield. Remove those and systems begin to degrade. Beyond Earth's magnetic field, high-energy cosmic radiation is constant. These are not gentle rays. They are relativistic particles capable of penetrating shielding and damaging molecular structure directly. DNA does not negotiate with them. It breaks. To protect against that radiation, shielding must be thick. Water, lead, dense material. But mass increases fuel requirements. Fuel increases mass. The loop reappears. Even if radiation were managed, zero gravity produces progressive physiological decline. Bone density reduces, muscles atrophy. The cardiovascular system adapts in ways that are harmful long-term. 6 months aboard the International Space Station is enough to require rehabilitation upon return. Now extend that to decades or centuries. Cryogenic suspension is often proposed. But freezing biological tissue forms crystalline structures that rupture cell membranes. Controlled preservation without structural damage remains unsolved. It is not an engineering footnote, it is a biological limitation. Generation ships are another proposal. Self-contained societies that live and die aboard a vessel for centuries until arrival. But long-term closed systems introduce genetic drift, mutation accumulation, and sociological instability. Maintaining stable culture, governance, and technological continuity for hundreds of years inside a sealed structure is not trivial. Biology is adapted software. It was written for Earth. It does not run naturally on deep space hardware. So perhaps the solution is to remove biology entirely. Send machines. Machines do not age in the same way. They do not require atmosphere. They do not suffer cancer. But they are not immune to entropy. High-energy particles cause bit flips in electronic systems. Radiation corrupts memory. Micrometeoroids traveling at extreme relative velocities impact with explosive force. Over thousands of years, materials fatigue. Circuits degrade. Lubricants evaporate. Even with redundancy, degradation accumulates. Long-duration autonomy introduces another difficulty: repair. A machine traveling for millennia must repair itself without supply chains, without maintenance crews, without spare parts beyond what it carries. It must predict every possible failure mode in advance. Entropy is patient. Now suppose distance, speed, energy, and durability are somehow addressed. Suppose a civilization survives the journey. There remains another constraint: communication. Electromagnetic signals propagate at light speed, no faster. Human radio transmissions have existed for roughly a century. That creates a sphere of detectable leakage roughly 100 light-years in radius. The Milky Way spans 100,000 light-years. Our signal bubble is microscopic. For another civilization to detect us, 3 conditions must align. They must exist within range, they must be technologically capable of detection, and they must be observing at the correct time and frequency. Civilizations are not static. Technological phases may last thousands of years, brief on cosmic timescales. The universe is 13.8 billion years old. The overlap window between 2 civilizations may be small. Even if intelligent life arises frequently, simultaneity is not guaranteed. One civilization may flourish and disappear millions of years before another emerges nearby. Temporal misalignment is not dramatic. It is statistical. Distance isolates space. The speed of light isolates time. The result is silence. Not necessarily emptiness, silence. And that silence is not mysterious when examined through structure rather than expectation. There is one more habit that interferes with clear thinking about this. When people encounter silence, they search for anomalies. They turn to blurred footage, unexplained radar returns, videos recorded through imperfect sensors. They see objects accelerating rapidly and conclude that known physics has been bypassed. But acceleration is not abstract. If a physical object changes velocity from rest to extreme speed in a short interval, it experiences force. Force produces stress. Stress produces structural consequences. Thousands of gravitational accelerations would not merely inconvenience material structure, they would overwhelm it. Electronics would deform. Mechanical components would fail. Biological tissue would not survive. And motion through atmosphere at extreme velocity is not invisible. Air molecules cannot be displaced quietly at such speeds. Shock waves form. Ionization occurs. Plasma trails develop. Thermal signatures appear. Physics is not selective. It applies uniformly. If an object interacts with air, air responds. If it accelerates mass, inertia resists. If it radiates energy, detectors measure. Extraordinary claims are not dismissed because they are exciting. They are examined because they imply violation of constraints that are tested repeatedly in laboratories. To overturn relativity or conservation laws requires evidence proportionate to that claim. Blurry imagery is not proportionate. This is not cynicism, it is proportional reasoning. Now step back from speculation and look at the broader picture. Suppose no civilization ever travels between stars. Suppose no ships cross the galaxy. What remains? The structure of the universe remains intact. The speed of light preserves causal order. The energy constraints that prevent interstellar empires also allow stars to burn stably for billions of years. The same limits that isolate civilizations also permit chemistry, planetary formation, and biological evolution. If faster-than-light travel were trivial, causality would collapse. Effects could precede causes. History would not be coherent. The constraints that prevent easy contact are the same constraints that make structured existence possible. Isolation is not an accident. It is a consequence of consistency. And that leads to a different conclusion than the one intuition suggests. The absence of visible visitors does not imply abandonment, it implies structure. The universe is not optimized for convenience, it is optimized for internal coherence. Civilizations may arise frequently, they may extinguish themselves, they may remain confined to their local systems, they may communicate slowly across millennia. But the physical framework does not favor rapid convergence, it favors locality. If life is rare, then we are statistically unusual. If life is common, then it is statistically isolated. In both cases, the responsibility remains local. No external intervention is guaranteed by physics. The silence in the sky is not necessarily a tragedy. It is a boundary condition. It tells you something about how space-time, energy, and matter are arranged. It tells you that expectation must yield to structure. You can continue searching. There is nothing in physics that forbids listening. There is nothing that forbids careful examination of data. But the search must respect constraints. Distance is not an inconvenience, it is immense. Light speed is not a hurdle, it is fundamental. Energy is not negotiable, it is conserved. Biology is not adaptable without limit, it is conditional. Time does not coordinate civilizations on demand, it separates them. When you combine those elements, the silence becomes understandable. Not mystical, not ominous, understandable. And understanding, even when it reduces possibility, is not defeat, it is clarity. We may never exchange signals with another intelligence. We may never witness evidence of technological neighbors. But we do share something universal, the same constants, the same conservation laws, the same atomic structure. The carbon in any hypothetical organism elsewhere would have been forged in stellar processes identical to those that produce the carbon here. Connection does not require proximity. It requires shared structure. If the universe is silent, it is silent according to rules, and those rules are what make inquiry possible. You do not need rescue from the sky. You need understanding of the ground you stand on. Physics does not promise companionship. It offers coherence, and coherence is enough.